Okay, we are recording day 2. So what I've posted from last time you can find on the lectures page, and this is what I expect to have every time. So the video of my screen, pretty long. And then this is a Python script that has all of the commands that I ran. And so one thing I was really annoying was, what I wanted to do was actually have everything, commands and output, like, in other words, everything that showed up in this window right here, I wanted to put in a file also. So what I did after class last time, because there were some problems like my console shutting down and restarting, I actually retyped in, copied and pasted in all the commands. So to recreate what was actually on my screen. And okay, I'll copy and paste that into a text file. Well, when you do that, it doesn't take these prompts. And so you can't, it's really difficult to read, like, what did I type in? What output was given? So I thought, you know what, forget it. I'm not going to type all those prompts in, all those zillion commands, especially because they're numbered. So what I have here, and I'll show you, okay, so this is a file that I've posted. So it actually has all the commands. But what I've done here, and it has everything that I typed in, all my comments, everything. So you could use this to recreate any part of last class. One thing, though, is there are certain commands and what you can do is, you can actually run this. But in order to make it runnable, like these commands right here, I actually type these at the prompt, uncommented. But if I actually try to run this as a script, it'll give me an error. So these are things you can type at the prompt, but not within a script. So that's one annoying quirk of Python, is that what you can type at the prompt can't always go in a script. But most things ran just fine. Let's see, I think. Well, yeah, there were a couple statements I did to intentionally generate errors, so I couldn't do that anymore. Okay, now what I'm going to do, though, is use this opportunity to show you how you can actually run a script, like from a command line. So what I'm going to do, and if I open up a terminal window, I wonder if I can make this bigger. Okay. Let's see. Okay, so I can try changing the font. Oh. Okay. So I'll make this size 20. Or will it let me? Okay. 21 it is. Okay. All right. So now if I close down this window and create another, good. Okay, so now I have a window that can be read. Now, what I'm going to do is, so if you're in Windows, you would open up a command prompt. And you would need to change to whatever directory your Python script is in. So I'm going to change to that directory here. So in my case, it's going to be under Documents, Courses, Math 684, Summer 18. Okay, and you could do, this is a Unix shell, so I would do ls to see all the files that I have. In Windows, you would do dir for directory. And here's the file I want right here, tutorial from June 5th.py. So what I can do is I could do Python, and then the name of a script I want to run. Okay. Oh, the first command was to print help, so that's why it's doing that. And then this was the output of one of the commands, like to print A equals 3 plus 4. Notice no other output appeared. That's because I didn't have any other print statements. Now, so that's another difference between what happens in the console as opposed to a script. That if you, so you can type certain things into prompt that will generate output, but those same things in a script will not. So in a script, you want to see output, like you'll need print statements or something of that nature. So, for example, if I go down to the bottom here, like here, I typed R by itself, and at the prompt in the console, printed the matrix. As run as a script, it didn't. So I'm going to change this to print R, and run the script again. And this time it prints the matrix. So that's one difference in behavior that you need to be aware of. So if you have any .py file with Python commands in it, so at your command prompt, so Python's very nice for command line scripting, unlike MATLAB, which doesn't really work that way. So you just do Python, whatever script name, and it'll run it. So that's quite convenient. Okay. So this is the tutorial file from last time. Actually, I'll restore it to its previous state. Does anyone have any questions before we before I continue with matrix basics and such? All right, so we really just tiptoed in last time. So in terms of even matrix basics, there's a lot more to cover. Okay, so how do we use Python to create vectors that are ranges of numbers? So similar, like in MATLAB, you would use the MATLAB, you'd use the colon operator to do this. And we actually will have a colon operator later when we deal with indexing, like to select certain rows and columns. But we actually don't use that to create ranges. Now, one fundamental aspect of Python is if I do range, let's say 10. So what that gives me is, it won't actually show me what the elements are. Okay. I'll just save this in something. Okay. Now, I need to do another way to show you what this actually means. Range with A and B is a list. It's a Python list of all the integers starting from the first element, A. So like the first element is 0, second element is 1, and so forth. However, and the last element, whoops. Actually, this is good that I made this mistake. Though I wish I could say it was intentional, but it's not. I went off the edge. Now, remember, Python uses zero-based indexing. Last element of x is not x10, it's x9. Okay. So, range AB is a Python list that starts at A, A plus 1, A plus 2, and so forth, all the way up to B minus 1. So, in other words, takes from the interval, and using mathematical notation, square bracket A parentheses B. So, and it'd be the integers. So, for example, if I make another range, now if I just put one number, it assumes that A is that's taken as B, and so range B is taken to be range 0B. So those two are equivalent. So if I make another range, let's say 4 to 12. So the first element will be 4, and the last element, oh, I went off the edge again. So it's numbers 4 through 11. So that's the last element. So 4, 5, 6, 7, 8, 9, 10, 11, it stops short of 12. Okay. Now we're going to see ranges used often to set up for loops. So like if you do like for I in range 10, that'll be a for loop that runs 10 times. We'll come to loops a bit later, but that's the most common usage I've seen is for iteration. But one thing about data types, range returns a Python list. Not the same as a NumPy ND array, which is what we're using for vectors and matrices for linear algebra operations. So there's actually another way, if you want an actual Python, like a NumPy ND array, we use a command for that. It's arange. Okay, so I'll show you how to use that. First, I need to import NumPy again as np. Okay, and I'll do like z equals np dot array. Now, well, actually, if I wanted a vector of numbers 1 through 10, I could always do this. But that's a little impractical if you want a vector containing all the integers from 1 to 1,000. We don't want to type all that out. So this is where we use arange. So I could do z equals np.arange. So you specify your first element, and then your last element plus 1. So I want the numbers from 1 to 10. So I need to stop at 11. So now if I have it to show me what z is, sure enough, it's the numbers 1 through 10. And describes it as a NumPy ND array based on this list. Actually, just for fun, I'm going to do the same thing. I want the numbers 1 through to 1,000. So that would give me arange 1 to 1,001. So I just want to see what happens if I ask it to print it out. Oh, yep, printed all of them out. Okay. So now here's another thing to be aware of when creating arrays this way. And that is, these numbers that I have in Z here, they're integers. By the way, anytime, especially when I have a lot of output like this, if you need me to scroll back, then just let me know. Not like I'm in some big hurry to get through all of this. Okay. So default array of integers. So if I want the same kind of lists, but I want floating point numbers, I did something similar to this last time. You can specify a d type equal float. Okay. So notice when I display it, it's 1 dot, 2 dots. So it has a decimal point here, so you can actually see these are floating point numbers. Okay. All right. Now, third argument specifies spacing. If I don't want them to be consecutive, suppose I want this. In MATLAB, it would be 1:2:10, which would be 1, 3, 5, 7, 9. I can do this. A range. Start with 1. Stop at 11, or I could have used 10. And a spacing of 2. And that gives me what I want, 1, 3, 5, 7, 9. So the third argument is the spacing. Okay. Okay. Now, this is an opportunity to show you something else that's unusual about Python compared to other languages. Here, I specified 3 arguments: the start, stop, and the spacing. Up here, I also had 3 arguments: the start, the stop, but I didn't want this third argument to be interpreted as a spacing. I wanted it to be interpreted as what type I wanted. So I say dtype equals. So in other words, the position of this argument doesn't matter. You can have it anywhere in your argument list as long if you specify the name of this argument being dtype. So it understands that. So this applies to whatever optional named arguments it has. Whereas these arguments need not be named. These will always be interpreted as the start and the stop. So in fact, what I'm going to do now is pull up the documentation for a range so you can see how this is described. Okay, I want... Okay. Yeah. So here is a documentation for a range and all the interfaces. So the only required argument is the stopping point. So I could have said like a range 10, and it would give me the numbers 0 through 9. Anything in square brackets is considered optional, like the starting point or the spacing, or we refer to it as the step. And then there's just one named argument, a dtype, and by default, so this is an actual Python type called none, so it's typeless. But a range will take that to mean, oh, they just want integers. Or if you start and stop are floating point numbers, then it would go with that. So in other words, it's using its own judgment as to what the type should be. But if you give it integers as arguments, like start and stop, it would default to an integer. Okay. Now, Python has a linspace function just like MATLAB does. It works the same way. And I'll get to that momentarily. And notice it's happy with an interval, but stop is not included. Okay. Okay. So it's a good idea if you're not sure what a function does. If you go to the SciPy documentation, and I have a link to this on the site, you just go to the index, and you can look up whatever function. But notice when I was pulling up a range, there's 2 of them. But this one is in a submodule, numpy.ma. I didn't want that one. I wanted this one from the top level module, which chances are is what you want. Okay. All right. Now, just like in MATLAB, you can have negative spacings. So here I specify the stop, and then the start. spacing of -2. So that will start at 10, go in steps of -2 until it hits 1, and it would not include 1. Whereas, also, same behaviors in MATLAB, if I had these in the opposite order, starting from 1 to 10 with negative spacing, that's going to be an empty array. So to step backwards, if you want actual content, you have to specify the largest element first and then the smallest one. So again, it's consistent with how MATLAB would behave. Okay, actually, what I need to do, okay, I'm going to redo these commands with the MATLAB equivalents. I'll make sure that I consistently do that. Okay. All right. You can have non-integer spacings. So I can start at, suppose I want all the numbers from, this doesn't look right. Okay. 0 to 1.01 to 0. Spacing 0.01. So this would be the same as 0, 0.01, and 1. Now the reason why I have 1.01 and not 1 is I want 1 to actually be included in this. So that's why I had to go out a little further to make sure that happened. Okay. So linspace works the same way as MATLAB. You just need to NP in front of it. So for instance, numbers from 1 to 10, and I want 10 values. Okay. Now, we're actually, okay. Yeah, so 10 total values, and that's what it gives me. Whereas if I want, for instance, 1 to 9, 5 values, this would be equivalent to 1, 2, 10. So it gives me all the numbers, odd numbers from 1 to 9, including 1 and 9. Notice they're automatically floating point numbers. So that's the default behavior. So with linspace, the default is floating point. Okay. So now, there's something I want you guys to try. Use linspace to create Z with numbers starting from 1, 1.01, 1.02, etc. So spacing of 0.01 all the way to 10. Well, linspace would create floating point numbers, so I'll write them as floating point. So what that means is you have to know how many numbers this would be. So you know you want your starting point to be 1. You know you want your ending point to be 10. So what I want you guys to figure out is, since so I'll put a question mark here. So I better not hit enter. So if this is the spacing you want, 0.01, what should I put here? What you can do is, if you have a guess, you could go ahead and try it yourself and see if it generates the right numbers. And if not, then you need to adjust. So you can try to figure out analytically. If not, maybe just fill something in there and have it display z. So in fact, I'm going to fill in something that I know is wrong. 100. Whoop. Oh, sorry, I goofed. np.linspace. Okay. So for instance, here spacing ends up being 0.090909, but I want 0.01, so I had far too few numbers. Yeah.
The last number is kind of the length of the...
Yes, how many numbers will actually be in the array? So that's has to be more than 100 because here the spacing was too large. If you have an answer, go for it. Warmer, but no. Yeah. So 1,000. That'd be closer to the mark if the starting point was 0 instead of 1. What? So, I'm sorry, I can't. Okay. Yes. Yeah. So this had the right starting and stopping point, 1 and 10, but just having also a correct spacing in between. So the second element should be 1.01, etc. So yeah, so it should be starting like this. Okay. Look. Okay. Look at this extreme example. I want spacing of 0.01. This has spacing of 0.09 something. So now, so in other words, because the spacing is too large, I have too few points. Because you're dealing with the interval 1 to 10, so that tells you how to adjust your guess. So, well, so what was your, what? 900? Almost. Spacing is still a little too large. Yes, it is. 901.
So you take the interval, find out the difference, how many units in the interval, divide by your spacing, and then add.
Let's see. Well, okay. Yeah, because you have to account for that endpoint.
So explain that again. So you take your interval 10 minus 1, you divide by 0.01, you get 900, you add 1.
Yeah, because you want that spacing, so that gap, that b minus a, and then you're dividing by the spacing, that's the total number of, not points, but sub-intervals and then the number of points has to be one more. Okay. So that's how you generate that using linspace. The equivalent command using instead of linspace arange, you would start at 1. You'd have to end at not 10 but 10.01 because in arange the second endpoint's not included. Spacing of 0.01, but also dtype equals float. And that would give you the same result. Okay. Okay. Now, any questions up to this point? Oftentimes, though, even if you're working with generally floating point arithmetic, when you're using ranges, you most likely will often want ranges of integers, just because when do you most often use ranges? With indices, and you'd want those to be integers.
So which way is preferred?
Between linspace and arange? So really, it would depend on the usage. For example, I would say that if you are setting up a grid, like if you're solving a differential equation, chances are I'd say linspace would be the one to go with. Whereas arange is it's nicer for working with indices, because arange has a behavior of leaving off the last endpoints. Made it. Okay.
My car broke down.
Oh yeah, I got your message. Okay. So actually, the funny thing is, when I was all the years I've been using MATLAB, it took me a long time to even find out about linspace. I just used the colon operator to do it myself. But ranges are nice for setting up loops and such. That's probably where you most often use that. Okay. You have a question? Okay. All right. So I'll do one more item before our first break, and actually, it's actually independent of what I've just been doing, so you can just watch the video later for that. Okay. So for building up larger matrices from smaller ones. Okay. So what I'm going to do is I'm going to create a few matrices here to work with. So this first one will just be a 2x2, and I'll make sure to type the MATLAB equivalents next to them. That'd be easier to read as to what matrices I'm creating. So here we have a 2x2, and then I'll make another matrix that is a 2x3. Okay, B equals. Okay, -1, 4, 5, 2, 5, 6, 7. Okay, and then I'll create one more. That is a 3x2. But yeah, it's easy to get like lost in all the square brackets this notation here. Okay, -1, -1, 2, -3, 5, -4. Okay. Now, first, in MATLAB, you can concatenate matrices horizontally and vertically. And you can in Python also. So A and B have they both have 2 rows. So I'm allowed to put them next to each other to make one matrix that's 2 rows and 5 columns. So the function for that from NumPy is called hstack, horizontal stacking. And what you do is you put A and B in a list, really, it's not actually, I shouldn't say list. In Python, a list is delimited by square brackets. When I have parentheses here, it's called a tuple, like an ordered pair. So if I go ahead and do this, so the MATLAB equivalent is x equals A, B. So you're putting B on the right of A. And sure enough, I have this matrix of 2 rows and 5 columns. Okay. Now, I can also go vertical. And predictably, function for that is vstack. So B and okay, not B. A and C have both 2 columns. So I can put A on top of C. So MATLAB equivalent is y is equal to A semicolon C. So now we have this matrix with here's A right here and then C below it. Okay. But if I try this operation, vertical stacking A and B, why can I not do that, given the A and B that I've defined up here? Well, sorry. Yeah, the number of columns is different. So in fact, if I go ahead and try this statement, yeah, that's cryptic error messages. All the input array dimensions except for the concatenation axis must match exactly. So that's its way of saying that the number of columns is. Oh wait, that was my statement there. But this is a fancy way of saying that the number of columns didn't match. Similarly, if I took A and C, these matrices, and tried to horizontally stack them, I could not, because they do not have the same number of rows. Okay.
Can you go back up to after you did the first vertical and horizontal stack?
Yeah. Oh, this one? Okay. 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 Now, I'm going to create an empty array, which you can do. You make a list of pass array function list of no elements. So it's the same as in MATLAB. If you do x equals empty pair of square brackets, then by default floating point numbers, there's just nothing in it. Okay, so then if I want to add elements onto it, say if I want to tack on elements to X in a loop, for example. So what I could do is I can make a list where first element is X itself, and then if I want to add a single number onto it, I make an array using that number. So that's the same as X is equal to X and then 1. So now, okay. This is weird. I want to see what happens. I didn't try this earlier. If I just put a 1 onto it, it'll let me do that. Oh. Wait, I need to reset it back to where it was before. Okay. Now I'll try this. You know what? I don't think this is a good idea. Yeah. I mean, tactically, you can. Like, I could go ahead and add more elements onto this. But the structure would not, it wouldn't be a clean array. So, on the other hand, Python lists elements with append. So, for example, if I make X, instead of a numpy array, I make it a list. So first there's nothing in it. And then I can append 1 onto it. And let's throw in a few other numbers here. And now it's list 1, 2, and 3. So if you have a operation where you need to build up a list from nothing, a list of numbers from nothing, you might find it easier to work with a Python list. Although, now I see what was going wrong. I was typing in the wrong thing. Okay, so that's what you do with lists.
Can you load a list into an array?
That's actually how you create arrays. In fact, if I go back to the last time I did that, up here, this is a list. It's a list of lists. Yeah.
Instead of specifying by the actual items in the list, you just specify the list name.
Yeah. Like if I made a variable that was a list, I could. Okay, so to show what David's talking about here. Okay, so if I make numpy array from X like that, where X is a list, and yeah, that's so that's how you can go back and forth. Okay, but how is trying to imitate malloc concatenation? That was incorrect. I should have been using hstack. So if I make okay. Okay, so I'm going to delete this crap from the log. All right, so first empty. Okay, and then I want to stack, and then I make an array with only the number 1 in it. And that is equivalent to horizontal concatenation. And sure enough, it's just an array of 1. And I could keep doing that. Like now I want to add 2 onto it. Or if I want to add several numbers at once. Whoops. Like now I want to tack on 3, 4, and 5. So now I can make a array with 3, 4, and 5. And it does it that way. Okay, so here working with just ND arrays, you can build up vectors of floating point numbers that way. Okay, but now, if you want to build up a column vector, of course, you can always do what I just did with a row vector and take the transpose. I haven't talked about transpose yet, but that's coming soon. But to make an empty column vector, I have to start slightly differently. Notice I have 2 sets of square brackets. Actually, I'm going to do both and show you the contrast. Here's what I did before. Empty array. I look at the shape. No rows, and then for columns, it doesn't even have anything. Whereas if I nest square brackets within one another and look at the shape, now it says there's 1 row, no columns. But at least now columns actually are defined for this entity. Okay. So now what I can do is, if I do vstack, and I have x, and then I have oh, it didn't like that. Okay. And for some reason on my paper here, it may be transpose. I need to transpose it. And now, this is a column vector. The double square brackets indicates it's a column vector because it's a row containing a row of 1 element. But now, if I want to tack on 2, I don't have to transpose this time. So if I look at x, and now it's generating a column vector with 1 and 2. And I can keep going if I add on 3, 4, and 5. But now I have to add on 3, 4, and 5 as a column vector. So look what I'm doing here. I did something like this last time, where I give each element its own row. And that's how you define a column vector. Okay, what did I do wrong here? I might have missed a parenthesis or something. Oh, yes. I missed square brackets. You have to close the whole thing in square brackets. Okay. So here, a list of lists. The outer list has only 1 element. And then there's... sorry, the outer list has 3 elements. Each inner list has only 1 element. Okay. All right. Now, a lot of times in MATLAB, I've had loops that build up vectors, row or column vectors like this, which is why I want to show you how you would do something similar in Python. The only thing that bugs me here is that I had to handle 1 differently than all the other elements. So what I could do instead is if if I create the empty one, but I transpose it right away, dot capital T will take the transpose of an ND array. And I'll get into more transposes later, but here's how we would do it here. Okay. Okay. So then the shape is no rows, one column. So I needed to have a column.
Yeah.
And that's why I need it. And then what I can do is now, as I tack on elements, I no longer need to transpose. Okay, so those are the correct statements there. Finally, dang it. Okay. So because it's defined to have one column, it'll continue having one column. Okay. So this right here, because I've made it a list of lists, is a two-dimensional array. Whereas what I did before, there's only one set of square brackets. So it's a one-dimensional array. So whatever nesting level of lists you have indicates the number of dimensions that it'll have in its shape. Well, now I'm wondering, since this is the shape that I wanted for X, no rows, one column, how that could have been done without transposing. And I'll bet there's another usage of array that allows this. Okay. Okay, here's the function I want. I think what I could have done alternatively is, instead of using array, let's try this. Zero matrix. I can specify the shape. No rows, one column. And it does have a shape I want. So this is a cleaner way of creating app. Thanks. Okay. All right, this is a bit of a misadventure here. Any questions about this kind of stacking? All right. So remember, row vector, use array, and all of these elements, however many you have. Column vector, you make each element its own row. So that's how you let Python know of your intent, what kind of vector you want. All right. Okay, we'll take our first break at this point. So we'll go back a little bit after noon and deal with accessing entries, rows, and columns. So what happened?
Oh, I was driving along 59, and then it just started decelerating.
Oh.
And I was like, what's going on?
Dang.
Pulled over and tried to start it. Then I tried to call the tow truck where I called State Farm, tell them where I was at, and walk out, and try and look at the next exit sign because they didn't like my ballpark estimate. You know how it is, you drive the same thing. remember what I just passed.
Yeah.
But anyway, I walked out, walked back to it, and I saw this huge puddle underneath it. So either
Oh.
was leaking transmission fluid or fuel. It just got.
Oh
I
man.
don't know.
Okay, now we're recording. Before I continue, one resource that I posted on the site that I'll draw your attention to, something if you want, you can do off to the side. This is actually it was actually one of my first exposures to Python from just going through Code Academy, where you can step through a lot of simple exercises to get some of the basics. That's just for Python in general, not related to scientific computing. So that might be a good supplement to get accustomed to syntax of working with lists and loops and so forth. And a lot of these things that you see we'll come to anyway, but it might be something that's good idea for you to do on your own to help build your foundation. So this link right here, that would take you here, just like this course. Not that one. That one's not free. This one is. Oh. Okay. All right. So, accessing and changing entries of matrices, whether it's an individual entry, which we'll see first, or dealing with entire rows or columns or portions thereof. So I'm going to make a matrix to start, just to have something to play around with. Let's see. And as usual, the MATLAB equivalent. Okay. Now, remember, indexing is zero-based. So, for instance, I want, if I choose a 0, 1 entry, which in MATLAB is the same as 1, 2 entry. So, first row, second column, and that entry here is 3, and sure enough, that's what we get. Okay. Now, let's see. Actually, I'm going to create a slightly larger matrix. Yeah, very slightly larger. A 3 by 3 to take entries from. So now what I want to do is I can use a colon operator like in MATLAB to, in fact, in most cases the syntax is very similar, except you use square brackets and then the zero-based indexing. So if I do row 0, and then notice the range here, if I want to take the, so another key difference is how ranges are interpreted in Python versus MATLAB. So if I want row 1, columns 1 through 3, so the entire first row in this case, notice even though there's a zero-based indexing, I stop at 3, not 2, because this ending point is excluded from what's actually used. Oh, thanks. So this will extract the entire first row. So that's one. So MATLAB, a colon b is equal to a plus 1, etc. up to b. But in Python, the same expression is a plus 1, etc. up to b minus 1. So beware of that. So something to get used to. So if you forget that, you do something like this: 0 colon 2 rows 0 colon 2, and then column 0, which is the first column. That's equivalent to a rows 1 through 2. So that will just take. So notice these are the first 2 entries of the first column. Also notice that whereas MATLAB would extract this and make it a column vector, it just takes it as a one-dimensional array, which can be thought of as either a row vector or a column vector. So it's no longer just something that's technically a matrix that has either one row or one column. It's really a one-dimensional array. So it's part of a column, but not a column vector. So in fact, if I go ahead and save this as a variable, I'll call it x, and look at its shape. So it only has one dimension. Okay. So for instance, if I want the leading 2x2 submatrix, so I would do 0 to 2, 0 to 2. That's the same as rows and columns 1 to 2 in MATLAB. You see it takes that 2x2 there. Okay. So when you're taking both rows and columns like that, multiple rows and columns in both cases, then it still retains the shape of the appropriate matrix. Okay. Now, you may remember in MATLAB, if you want to take, say I want an entire row or column, and you can use colon to specify the whole thing, that works in Python too. So if I do colon, comma 2 for my indices, that is the same as, so remember, zero-based indexing, so that would be the third column. But again, converted, so you see here's the original matrix. It takes the third column of it, but again, it's a one-dimensional array. And that goes both ways naturally, so 0, colon, comma, that would take the entire first row. So even though this was a column, this was a row, the output, the result, is still something of exactly the same shape, a one-dimensional array. All right. Now, another shortcut that MATLAB had was for indexing. You could use the keyword end to refer to the last possible index. Python doesn't have that exactly, but it has something that's equivalent. It actually gives a meaning to negative indices. So what I'll do is I'm going to put original A back up again. And now if I do A colon comma -1, and let's see what it takes. It's the last column. So, so equivalent to A colon end. Okay. Another shortcut is, let's suppose I want to take from the second row all the way to the bottom. So for that, well, the second row is index 1. And then I put a colon and then nothing else. So it's 1 colon, that's the whole index, and then 0. So that's equivalent to rows 2 all the way to the bottom, column 1. So first column, and then it takes these last two entries as a one-dimensional array. Okay. Also, if you want to take like not a range of rows, but selected rows. Like for instance, suppose I want to extract only the first row and the third row, not the second. So I can use a list of indices. So this is a list of indices referring to row 1, row 3, and then all columns. So that is equivalent to MATLAB's rows 1 and 3, and then all columns. So here we took the first row and the third row. Okay. And you can do the same if I want selected columns. So I want, like for instance, suppose I want to take the third column, and then the second column, but I want the third column to be first. So that would be equivalent to this MATLAB expression. So you can take... Yep. I've only caught it 2 seconds sooner. Okay. Okay, so here we have third column down here, and then second column down here. Okay, so all the different kinds of indexing operations that you can do in MATLAB, or there's similar ways to do them in Python. Okay. Now, one thing that was rather difficult, and I have, like, suppose you want to take selected rows and selected columns. Now, I have a way of doing it here in my notes, and apparently the way I thought I might be able to do them must have turned out to be wrong. Like, so here I have third column, second column. Suppose I want to take first row, second row of those. So based on what's in my notes, this is something that would work this way in MATLAB. Something tells me it's not going to work here because I don't have it that way in my notes. I just don't remember what happened. So I'm going to try it and see what we get. Yeah. Not the correct result. Because it takes the first element of column 3 and then the second element of column 2. So what I really wanted was to take entries 0 and 1 of column 3 and entries 0 and 1 of column 2. But what it did is it did like a one-to-one correspondence. So instead, the MATLAB equivalent is, like, basically it's a vector consisting of A, row 1, column 3, and row 2, column 2. So that's what actually happened in this case, where it says it pairs up this index of this one, this index of this one. It doesn't interpret as taking all possible combinations of entries, which is what I wanted. So that's one cautionary tale about that. So you can use these lists of indices to take entire rows or entire columns, but if you put both, it won't give you the result you wanted. So, in fact, I'll bet, suppose I do this. I'll put another index in here, 201. Gives me an error because it can't pair all the indices. So now the problem is, if I want to take a submatrix where I'm taking certain rows and certain columns, how can I do that? Well, fortunately, there is a way. I'm actually going to show you 2 different ways to do it. Okay, so what I'm going to do is I'm going to make a random matrix 5 by 5. Okay, so here's what I can do. If I take all right, so what I want to do for MATLAB syntax, I want to take rows 1, 4, and 3, and columns 5 and 2. Okay, so here's what I could do. I could do this kind of like one at a time in a way. If I take all all rows, and I specify the columns first. Startled me. So columns first. So 5 and 2 would be columns 4 and 1. Okay, so that'll take the entire columns. Then I use another set of square brackets to take rows 0, 3, 2 from those columns. And that works. So here we see column 5, column 2, but taking elements 1, 4, then 3. Okay, so that's one way to handle that. Another that is a little cleaner there's a function called take that's useful for extracting submatrices. And I'll show you how you can use it here. So if I take and I specify the rows first, 0 for each 2, and the second argument indicates what axis you're referring to. I use axis 0 to indicate I want rows. So in other words, what I'm saying for the second argument of 0 is interpret these indices as row indices. So that'll extract the rows I want. Okay. And then from that submatrix, I can call take again and extract the columns. And here my second argument is 1. So axis 0 means rows, axis 1 means columns, and that'll give me the same result. So you can always use take to extract submatrices. Still one at a time, like here you take the rows, take the columns, or I could have done it in the opposite order, it wouldn't have mattered. But you get the idea, hopefully. Okay. All right. The funny thing is, though, like when I would tell people that I was using Python, I might post something on Facebook about it or whatever, and I'd express that I'd find it kind of a pain to use, and people were like, "How could you not love Python? Python's amazing," and so forth. And I explained, like, well, I'm trying to do numerical linear algebra, working vectors and matrices, and then it's like, oh, okay. So for people who are accustomed to MATLAB and they love the really convenient matrix vector syntax, that's like one of the barriers to becoming a Python person. Is that yes, there are a lot of conveniences. You can pretty much do all the same things, but it's, as you can tell from what I'm doing here, it's pretty cumbersome. So.
What would a person be doing to prefer Python?
I guess it's all the other stuff, but well, it has other language conveniences. Like it's so nice to work with lists and so forth, and other intuitive features. So, oh, it locked. Okay, hey, you can unlock that. Yeah. Okay. Yeah, because it's bound to happen again. I guess. Yeah. Plus the fact that it's free. But the scripting aspect is kind of nice, and its extensibility and all that. But yeah, something a lot of people have written about. So like, and I've read these articles about why switch to Python. I'm like, okay.
You wouldn't want to do KSS with Python.
Well, I figure somebody ought to do it sometime, but yeah. And
is that a hint?
well, and I still think having a Python edition of a book is a good idea, just because people would demand it. But yeah, I'm not sure what it will take to make me a fan. It's one of the reasons why I'm teaching this class. to see if it'll, like, if going into it that in depth will change things. So,
How does the libraries, like the pre-written modules things in Python that are available versus what's available?
in terms of, well, um, in terms of like well-tested, well-established things, there's actually probably a lot more in Python.
More in Python?
Yeah, just because in MATLAB, what are we looking at? We're looking at the toolboxes and whatever it is that MathWorks alone puts out, pretty much. And there may be like, because other substantial software packages that people put out, they wouldn't put them out in MATLAB. They put them out in like Fortran or C or something like that. That's where the very best mathematical software is, but it's also really hard to produce. So it looks like SciPy and NumPy are pretty big. There's a whole lot in there. And I think it's simply because it's easier for people to make contributions to it. Now, all of that stuff has to be very thoroughly checked before it becomes like canon. But I think if people want to add features to it, it's a lot easier to do. And also optimize those features. And like when we see issues with MATLAB, we're like, we kind of have to accept it. And yeah, you can always submit bug reports and so forth, but having been on that side of things, well, I know this isn't getting fixed anytime soon. Okay. Okay. Thing. Okay. Now, so here's some unusual syntax for how to reverse rows and the columns. So if I have my matrix A from before, I can do, starting from the end, going back to the beginning, which is specified just by, I could put a 0 here, but by putting nothing, it's assumed to mean the beginning. Spacing of -1, and that's for the rows. And I do the same thing for the columns. But now we'll get the job done, that the rows and columns are in reverse order. And also, this is something got to be nice for something we'll be seeing later. For example, Gaussian elimination with pivoting. You want to swap rows. So if I'll pick an I and j at random. So I equals 0, j equals 2. So swap rows I and j. So here's my original A. If I say A and I specify indices I and j equals A, j, I, that's the easiest way. So MATLAB equivalent is Aij all columns equals A, j, I all columns. Okay, I'll print it out. And sure enough, the first and last rows 0 and 2, are switched. So that's how you would handle partial pivoting, for instance, where you need to perform row interchanges. Now, one thing that was interesting from what I just did up above, here, if I have ranges of indices, rows and columns, it let me do that. Whereas if I specified lists of indices, where the indices could be in any order, that did not produce a result that I wanted. So I'm going to try something else here. Well, actually, you know what? I did earlier. The MATLAB syntax produced that. So when you have ranges of indices, you can extract a submatrix dealing with both rows and columns and do it all in one shot. It's when you want to scramble both the rows and columns, so if I do this, with L1 and L2 list of indices, doesn't work. And I say work in quotes, and I say it doesn't work in the sense that it doesn't produce what the similar expression in MATLAB would. So it's kind of interesting, the behavior. I'm not sure why they designed it like that. I think it's kind of aggravating, honestly. But maybe someone thought that the other way of interpreting it was convenient. Because this... Oh, wait. That should be square brackets, not parentheses. Okay. All right. Because also, in Python, these lists, L1 and L2, must be the same length, or as we saw earlier, it gives you an error. So, yeah, but it's a little strange, the behavior. So you have to be careful about that. Okay. Now, okay, so I'm actually going to talk about two related topics at once: complex numbers and transposes. Okay. So if I want to create complex numbers, you can have imaginary units that's denoted by J rather than I. Well, I think using J as imaginary unit in MATLAB works as well. So I'm going to create an array of two complex numbers. So, well, real number 6, and then 3 plus 4J is the complex number of real part 3 and imaginary part 4. Okay. So you can extract real imaginary parts similar to how you could in MATLAB. So if I do z.real, so real is part is an attribute, so that's the same as y equals real of z. So that just takes the real parts of both. And you can also do imag, similar to imag function in MATLAB. So it takes the imaginary parts 0 and 4. So once you have any element of an array be a complex number, everything is considered complex. So in terms of storage and so forth, just like in MATLAB. So when you have a lot of complex imaginary parts that are produced by round-off error, I want to just take the real part, because otherwise you're wasting storage. Okay. Now, to recall something that I did last time, dealt with a quadratic formula. So I'm going to produce coefficients of a polynomial that has complex roots. So if I do this, same quadratic formula as last time. Well, first I'm going to import square root, so I don't type math dot. So if I do this and get to root, this is exactly what you guys did last time with a different polynomial. B squared minus 4ac over 2a. What's going to happen is, because this polynomial ax squared plus bx plus c has complex roots, it's going to give me an error. So the square root function from math is not allowed to take square root of a negative number. So that's different from MATLAB square root, where it doesn't care what you give it, it'll take the square root. So you need a different package, CMath. So here's what I'll do. I'll do from CMath import square root, but I'm not gonna do this exactly, because this square root has the same name as the other square root. I don't want a name conflict, so I'm going to give it an alias. Import square root as C square root. So that'll refer to the square root from the CMath package. That way, I can use both square root and C square root easily. So now I can try this again using C square root and it works, and we have -2 plus the square root of 5, I, or j, imaginary part, as the root. And I can do the same thing to get x2, which would just be the complex conjugate. And then I can substitute these into the quadratic equation. And sure enough, it gives me the complex number 0. And that would happen for the other root as well. Okay. So suppose I make a variable theta to be pi over 4. So that'd be math.pi. Whoops. Oh, that's weird. Oh, that's freaky. Oh, it makes sense though, because I imported square root from math. I did not import math. Fine, I'll import math. That's annoying. Okay, so now I have pi over 4. So now I'm going to call cosine of theta sine theta. So now I can make a complex number. Cosine theta plus I sine theta, but I'm specifying it using 1j. So there's my real part and imaginary part. So that's how you can specify a complex number that way. And if I import CMath, I can do e to the I times theta, but again specified by the 1j. And that gives me the same result, because e to the I theta is equal to cosine theta plus I sine theta. Euler's formula. So, or Euler's identity. Okay, so use j or 1j to refer to the imaginary unit, or any numeric constant with a j appended is taken to be that imaginary number.
What's the difference between math and math?
Oh, complex math.
So doing anything on complex numbers.
Yeah, or if you're doing something that could produce a complex number. So actually, I'm going to try another example. If I take, actually, I honestly don't know if, okay, so log, similar to MATLAB, log is a natural log. So if I do math.log, let's say -2, sure enough, it gives me an error, because you can't take a log of a negative number. So now let's try CMath, and we get a result. So sure enough, that'd be log of 2 times e to the I pi, which is -1. Okay. Or this pi times I is a log of natural log of -1. Okay. Yeah. So because notice it says here domain error. So math will restrict the domain of functions like log or square root. CMath doesn't. Okay. Yeah.
Why do they choose J instead of I? Is that simply because J is easier to see in the text, or is there some convention?
Yeah, that's a good question. And actually, I'm pretty sure if it's because I tried I before. Yeah, I didn't like it. I thought, oh, maybe I'll take J. Yeah, whereas in MATLAB, you can do either one. I think you're allowed to refer to J. Not sure why I is sacred. Okay. Oh, yeah. Okay. All right. So reason why I want to bring in complex value numbers was to give a more thorough discussion of transpose operators. Okay. So if I make an array, like the numbers 1 through 10. Okay. Now if I do z transpose, so I can do dot transpose with no arguments, take a transpose, which is equivalent to z dot t. So it's a shorthand for it. Well, that doesn't do anything. And the reason why is it's a one-dimensional array. Transpose only makes sense on higher dimensional arrays, like matrices. So for example, suppose I give, I do this. So now it's an actual array, and the shape is 1 row, 10 columns. So now it makes sense to take the transpose. And it's a column vector. So if I do z.t.shape, that's 10 rows, 1 column. So when you create a two-dimensional array of any kind, then transpose will do what you expect and swap dimensions. But now, let's create a complex vector. And I have, and I'm using 2 sets of square brackets because I want to make it a two-dimensional array. It'll be a row vector. Okay, so this is my row vector, and the shape is 1 row, 2 columns. And now, I'll take a transpose. Okay, and that makes it a column vector. Now, z dot capital T is not equivalent to z apostrophe or z single quote it's not exactly the same. Can anyone tell me what the difference is between the two? What does this operator actually do in MATLAB? What? Yeah. Yeah, like so this expression in MATLAB, but it's not exactly the transpose. There's something else about it. Let's see if anybody remembers. I'll go to MATLAB, in fact. I'll create the same vector. 6, 3 plus 4i. All right. Okay, now I'll do z. What's different? Because here we have what the MATLAB version. Here's the Python version. What's different? Yeah. So z transpose is the Hermitian transpose. That takes a transpose and a complex conjugate. So z dot t is equivalent to MATLAB's z dot apostrophe. So that's one thing to be careful about. So in Python, the default behavior is just plain old transpose, whereas in MATLAB, the default is Hermitian transpose. And the reason why is typically linear algebra operations or results that are established for real vectors and matrices, the appropriate generalization to complex numbers is to take the Hermitian transpose. But Python wanted .t to really mean .t. Well, now I think about it, I wonder if .h is a thing. Nope, it's not a thing. Okay. I think it should be. Okay. Well, if I ever have a chance to make extensions to NumPy, that's what I'll do. That'll be my contribution. Now, if you really want the Hermitian transpose, you can. It's just more cumbersome, like so many other things in Python are. Take the conjugate first, and then take the transpose. So that'll negate all the imaginary parts. Okay. All right. All right, we'll take a short break at this point. Okay. As a last precursor to be able to get more interesting expressions, we're going to veer away from mathematical expressions, deal with conditional and relational expressions, so dealing with logical entities. So starting with conditional expressions. Okay. So we have similar relational operators. So now if I do like 4 greater than 3, so this is a Boolean or logical expression that has a value true. But equals is the same meaning as in other languages. So these values true and false represent the values of logical expressions. So the relational operators are so equals. It's exclamation point equals as opposed to the tilde equals from MATLAB. But this is the same not equals that you see, for instance, in C and C++. And then everything else is as usual. Okay. And then on logical operators, you actually spell them out. And, or, and not. So, for example, if I do something like 4 greater than 3 or 1 equals 0, well, one of these expressions is true, so the whole thing is true. Okay. Or I could do like not 1 equals 0. But 1 equals 0 is false, so that negation makes it true. So that's one key difference in syntax. Equivalences. So and is similar to MATLAB's double ampersand, or is equivalent to the double vertical bar, and not is equivalent to MATLAB's tilde. Okay. So I was thinking to make a MATLAB Python Rosetta Stone or something.
Actually, it sounds like pretty useful.
Yeah. Now, on the other hand, one thing that does work the same way as in MATLAB is operating on matrices. You can use a single ampersand or the single vertical bar for forming component-wise. So, as an example, I'm going to make 2 random vectors. So now I'm going to do, okay, let's look at x and y, random numbers between 0 and 1. Although, actually, you know what? I don't like this example, because all the numbers are less than 1/2. I'm going to do it again. Give me something better. Still don't like y. Okay, that's better. Okay, so now I'm going to do x less than 1/2, or y is less than 1/2. And that gives me true, true, true. Because if you look at x and y, so first one, this is less than 1/2. Second row, this is less than 1/2, that's not. Then in the third row, that's not less than 1/2, but that is. On the other hand, if I do like x less than 1/2 and y is less than 1/2, I use an ampersand. False, 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 because in every single row, one of the elements of either x or y is greater than 1/2. Okay. No. So if I try this, okay, random matrix. Actually, no, random vector. 10 vector. Numbers between -10 and 10. Which entries are in -1 to 1? So I'm going to make entry. So first, if I make a random matrix of length 10, but I want the entry, but these are between 0 and 1. So I multiply by 20 to make it between 0 and 20, and then I subtract 10 to make it between -10 and 10. So now I can do this. I do x is greater than -1 and x is less than 1. So sure enough, none of the entries are except for the 3rd, 5th, and 10th. So those are the only ones that fall in that interval. So now you have this logical vector that you can extract elements of, like for use in conditional statements, like we're coming to pretty soon, like if statements, while statements, that sort of thing. Okay. So any questions about the logical operators? Now, for the first time in this class, we're going to look at, a script file. This first one in this tutorial. Let's see, where is it? Oh, I'm in the wrong folder. Okay, I'm going to change to this folder and open up. Okay. Oh, okay, it's not changing on the folder over here. Fine, whatever. Okay, courses. Okay. Sine of x dot pi. Okay, I'm going to close this upper one. Don't need it. Okay. Now, here's our first example of an if statement. So, as you're typing this out, if you decide to do that, and I'll post this file later, along with the tutorial transcript. So here I'm making a number between -1 and -1 and 1. So I print out the number, and then note the syntax of the if statement. So it's kind of similar to other languages. So I have an if, and then my conditional statement, and notice the colon, very important. So the if line must terminate with a colon, and when you're typing this, Python's editor will indent for you on the next line. And then when you're done with this part that's indented, then you can just backspace on the next line. And elif is a shorthand for else if. So first it checks if x is positive. If so, it prints a message. If not, it comes down here and then checks, okay, now if x is less than 0, then it'll print another message. And then finally, determine if it else, also if a colon. Notice a colon in every single one of these lines. So what I could do is I could go ahead and run this just by hitting the green arrow here. And it comes up with a random number that's 0.48, and then it prints out the message that x is positive. Okay. So the idea is after the colon, that tells Python to indent. So indentation in other languages like C or MATLAB, indentation is not required. It's just a good idea to make your code decipherable. Python is actually required. So the way it's enforcing good coding practice. So it will automatically indent on this line and then all subsequent lines until you backspace if you want it to move on from your if statement or maybe have an else clause in there. Okay. Any questions about how the if statement is set up? Now I have another example. Okay. So this is a enter month year.py. So this is more interactive. Well, I'm going to run it first, and then I'll take you through the code. So I can use this arrow here to run it. Okay, so that's for a month. So I'll type in a month, let's say 2 for February. And then a 4-digit year, I'll pick 2016. And then it tells me that February 2016 has 29 days because it was a leap year. Okay. So you specify the number of a month, 1 through 12, and a 4-digit year. It'll tell you how many days are in that month, taking leap years into account. So here's how it does it over here. So first, I'll add some comments. So the input function, you give it a string. Notice the string's in single quotes, just like in MATLAB, as a prompt, and it will. So the user will have to type something in and hit enter, and that'll be gathered up as the input, and that is returned by the input function. But I want that input interpreted as a number. So int here takes what's returned by input and converts it as best it can into an integer. So now if I put in garbage, like if I go ahead and run this again, and I give it something that's not decipherable as a number, like A, it's going to freak out. Now later we'll talk about how to handle exceptions gracefully, so that you can see, like, okay, it tries to convert to an int, it can't. So then it can like prompt the user again, say, you entered something invalid, try again. So that's something we'll deal with at another time. But yeah, there's a lot that can be done and maybe should be done to idiot-proof your code, so that your programs don't crash when things like this happen. So you prompt for the month, and then you prompt for the year. And then here I have a Python list, but it's a list of strings for all the month names, January all the way to December. And what I do is I take the number that they typed in, 1 through 12, and I subtract 1 from it to I subtract 1 from it so I can use it as an index, because Python has zero-based indexing. So for instance, when I type in 2 for February, I access month square bracket 1, which is the second element, which is the string February, just so I can print out the name of that month later. Okay. So now that I have the month, I want to figure out how many days are in that month. Now, the most interesting case, of course, is February. So if month is equal to 2, that's what the user typed in, then I check here. I use this remainder operator, %. This is the same operator as in C and C++. It takes year divided by 4 and takes the remainder. So if year is divisible by 4, for remainder would be 0. So in that case, I know it's a leap year, so I set the days equal to 29, else 28. So notice that here I have an if statement nested within another if statement. So everything that's indented here applies only in the case where month is equal to 2. Now, if a month is not 2, then I have the other four special cases. Because most months have 31 days, but there's 4 other months that have only 30 days. So April, June, September, and November. So I just check those 4 cases. So if month is one of these values, 4, 6, 9, or 11, then I'll set the days equal to 30. If it's so, the remaining cases, the remaining 7 months, I'll have 31. So that's what I fill in my else case. So then what I want to do is print out a nicely formatted message stating how many days are in the month that the user provided. So what's nice in Python, you can't do this in MATLAB. Well, you can, it's just not as intuitive. You can literally add strings together. Notice I have month name plus, and then comma and a space plus. And then any numbers, I want to convert them to a string. So you do, okay. So strings can be concatenated using plus and string str to convert numbers to strings. Okay, so I have month name, comma, space, and then the year. So like, for instance, February, comma, 2016. And then the rest of my text, where I convert the days also to a string. And I just put the sentence together, and that is what is printed up here. Okay. So here we have an example of an if statement within an if statement, with compound conditions and so forth. Okay. So questions about anything, any constructs in this that you're not sure what they do or what they mean? So I should mention, one thing that was kind of a pain when I did the same thing in MATLAB is I couldn't create a matrix of strings just like this. I had to make sure that you can, but you have to make sure that all strings have the same length. So I just pad the shorter month names with spaces. And then use a MATLAB function called dblank to remove the trailing spaces. I also could have created a cell array. So it's very dealing with 2 different kinds of collections, so like a matrix versus a cell array. And cell arrays are notoriously slow. So some certain things about this script are actually a little more convenient than the corresponding script in MATLAB. So it seems to me, if you're not dealing with vectors and matrices so much, Python probably is nicer to program in. And I will admit that when I was going, like a few years ago, I went through that Code Academy course that I pointed you guys, and it was actually kind of fun doing their exercises, which weren't really dealing with scientific computing at all. But I will say that when I implemented certain algorithms from my book in Python, the ones of dealing with matrices most closely, like Gaussian elimination and pivoting, that was the pain just because you had to figure out the right syntax, like how to swap rows. I would try certain things I thought would work and they didn't. I had to look up what works. And now that I know, it's a whole lot easier. Doing other things, for example, time stepping for ODEs, implementing stuff like that, that actually wasn't bad at all. And so there's certain aspects of that were a little bit easier than they were in MATLAB. So it's just that if you're doing hardcore numerical linear algebra, you're probably not going to like it as much. Okay. So any questions about this script? Okay. Now I will start. I'm almost out of time, but so the first example of involving for statements. Okay, so that would be compute mean. Now, and Python has its own functions for computing means and so forth, but here I'm running a script. So I'm going to run this script that generates a random 10-length column vector, computes the mean of all the elements of a vector, and then prints out that mean. So I generate the random vector, print it out for the user to see, and then I'm going to let m will be the sum of all the entries of x. I say at first because I'm going to divide later. So I start out with m equaling 0. So now I have this loop. Here's my for loop for I in range 10. So that means that I will equal 0, 1, 2, 3, all the way up to 9. So range 10 starts out with 0, 1, 2, 3, counts up to this number minus 1. And which makes sense because 0 through 9 are the indices into your vector x. Now, if I wanted to make this a little more adaptable, I could have done this range len of x. So I could do that. So len of x, I'll do this out here, is 10. So that's something, if you have a vector that could be of any length whatsoever, you can always do this and have an I equaling all the indices into that array. So, and notice, this is shorthand for m equals m plus xi. So this is what you have to do in MATLAB. You have to do m equals m plus. Here you can do plus equals. So the accumulation operators that you may recognize from other languages like C and C++ are available here. Plus plus is not. You cannot do plus plus or minus minus. But plus equals, times equals, those kind of operators you can do. So then this loop adds up all the entries into m. And then notice I have m. Actually, I can make this more general. I could divide by the length of x. So here I have divide equals. So m equals m divided by its length. And then I can print out the mean. So because this line here is unindented, that means it's not included in the for loop. So only the indented statements are in the loop. So Python uses indentation to figure out what's what, where for and if statements or while statements, where those statements begin and end. Also, functions that we'll see also, indentation delineates the body of the function.
Where do you get length of x? It's just where you see it.
Oh,
It's just a command.
yeah. So this is one of Python's fundamental built-in functions. So it works on lists or NumPy's arrays. Any object that has this note for which notion of length makes sense. Yeah. Okay. Okay. So any questions about this for loop example? Okay. We'll continue with these kind of statements starting next time.
So if you wanted more than one command in your folder, you just don't tab back. Whatever you have indented is part of your folder.
Right. Yeah, and actually in other examples we'll see that. Yeah.